We are live. Good morning, everybody. It is Friday, woohoo, the 15th. Okay, we can do this. I know I say that every day, but we can. We can do this. We just work a little bit every day. It's easy. Okay, so first of all, there's some of you who have not finished Chapter 7. Hello, we're on Chapter 8. So if you haven't finished Chapter 7, get it done, okay? I will be calling and emailing parents today regarding that, okay? So now, next thing, let's take a look at our homework from yesterday. Pretty easy. It really is an easy chapter. You just have to work at it. Super easy chapter. So if I go to the homework from yesterday, I have, first of all, yes, these are going to be similar by angle. You can see that 75 degrees out of 90. These two add up to 90. If I did the math and every triangle adds up to 180 degrees, then I get 30 and 34, no, 116, 106, no. So you have to have, all the angles have to match up, but it doesn't work. Okay, number 3, to prove it or show it, I'm just going to mark it. I know that if these are parallel, then corresponding angles are equal and they both share angle C. So by angle-angle similarity, yes, we can say the triangle BCD is similar to triangle ACE. Okay. Same thing on parallel lines, alternate interior angles. Hopefully you learned that last year. So these two angles are equal by alternate interior angles, and these two angles are equal, so we can say yes by angle-angle similarity. In fact, I think they're probably congruent, more than just similar. I think they're congruent triangles, okay? On the back side, once you go ahead and 63, subtract from 180 degrees, 27, you can get all of your angles, so 27, 63. 3 squares of 5, which is really about 6.7. You can use Pythagorean's theorem to get that. That's pretty easy, okay? 9 is 3. FE is 3 halves, or 1.5. 3.35 again, either by Pythagorean's theorem or you can set up proportions. And so then you can say the triangle AGC is similar to triangle DEGF. Okay, so in the diagram we can say that these two triangles are similar, and the big triangle is similar to the little triangle. Okay, you see there's 3. This one to this one. There's 3 of them, right? Hold on. This one, purple to purple, and you can say the blue. Oh, it looks like different kind of purple. Oh, interesting. And then green, the big triangle to the little triangle. Okay, those are similar. Okay, all right. And 15, no, if you do the math, the angles don't match up, so it doesn't work. Okay, you get 34 degrees here, and then you get a 44 and a 46. Doesn't work. Okay, so it's no. So that's homework. So today's lesson, again, is pretty easy. I don't think that this is a hard chapter. That's the nice thing about it. Things that are similar are going to be proportional. So again, things that are similar. Same shape, different size. So what makes them unique is they are proportional, like half as big, twice as big, 2/3 as big, but they are proportional. Proportional. What does that mean? That they have a ratio, an R. And then in this case, what is the R? Well, let's take a look. First of all, let's find out what the proportion is in these two triangles. So first of all, what I want to do is look at these two triangles. They're kind of like, this one's kind of backwards. So let me rewrite this one. Let's draw this one like this. Let me redraw this one. And put my E up here. My D and my F. So if I turn it around, I can see the two triangles. I've got my first triangle here, ABC. I've got my second triangle here, DEF, and the question is, are they proportional? Okay, the 6, the 9, and the 12. So, what's the ratio? Well, let's see. 8 goes to 6, right? 8 goes to 6. I'm looking for a ratio, and again, the word ratio means fraction. Ratio means like a fraction, ratio or proportion. 8 goes to 6, as 12 goes to 9, as 16 goes to 12, okay? So I'm just going to match up corresponding sides. Okay? So now let's reduce all of our fractions. 4/3, divide by 2, divide by 2, divide by 3, divide by 3, 4/3, divide by 4, divide by 4, 4/3. Okay, so then we can say, yeah, this triangle, we can say that triangle, ready? ABC, we can say triangle ABC is similar to triangle, and you got to put it so everything matches up, DEF. So you got to put the angles that go together in the same order when you say they're going to be similar. D goes to A goes to D, B goes to E, C goes to F, and I write it. A goes to D, B goes to E, C goes to F. So when I write it, now SSS, what's it stand for? It stands for side, side, side similarity. So if all three sides have the same ratio, if all three corresponding sides have the same ratio, then the two triangles are going to be similar. So if all three corresponding sides have the same ratio, then they're similar. Okay, so we call it side, side, side similarity. All three. Now the sides are not equal. Don't get that wrong. The sides are not equal. 8 is not equal to 6. Duh. 12 is not equal to 9. Duh. 16 is not equal to 12. But the ratios of their corresponding sides are all going to be the same. So therefore we can say that the triangles are similar. Okay. Now let's take that information. So if I know the two triangles are similar, that's my given. I know that this triangle, triangle ABC, is similar to triangle DEF. Okay? And if I know that, then I can set up the proportions. Well, let's see. If I want to find the value of x, first thing I'll do is I'll set up the two I know. I'm going to go 4 goes to 12. See how these two sides correspond? So I'll say 4 goes to 12, and I'll write that down as 4 goes to 12. See, I write that as a proportion or a ratio. So 4 goes to 12 as x minus 1 goes to 18. Okay, now, how am I going to solve for x? Well, the first thing we do is, see this big divide by 18? Let's solve. So we undo it. Instead of divide by 18, if I multiply by 18, on this side, and of course I have to do the same thing on the other side. I multiply by 18. My 18s will cancel, right? And that's 18 over 1. Don't forget this 18 over 1. Now, what's 4 times 18? Well, that's what calculus made it for, right? Clear. It's 4 times 18 is 72. And then 72 divided by 12 is going to be 6. So I get 6 equals x minus 1, because x minus 1 is still there. Plus 1, x equals 7. Okay. Therefore, this side's got to be, if I put the 7 in here, the side's going to be 6, right? Okay. Now, then what's this side? Well, I can plug that in. I get 3 times 7 plus 1, 3 times 8. This side is 24. Okay. Pretty easy. Okay, turn the page. Okay, are these triangles similar? Why or why not? Oh, now here's another theorem. Okay, so let's talk about it. How to prove two triangles are similar. Remember, similar, same shape, different size. How to prove two triangles are similar? Well, we have. Yesterday we learned about angle similarity. Okay? We just saw side, side, side similarity. And there's one more, and that is side, angle, side similarity. Okay, let me circle this. Let me have these are the three ways we can prove two triangles are similar. Okay? So angle, that's easy. You have two angles, that's what we looked at yesterday. If two angles of one triangle is congruent to two angles of another triangle, they're equal. That makes sense. Not equal, they're similar. We just saw side, side, side. Okay, here's side, side, side. If all the corresponding sides have the same ratio, then they are similar. Okay. Now last one, this one here, is the side angle side. Now, the sides have to be proportional. So the sides, because they're not going to be equal. Take a look. 4, 6, they're not equal. 4 and 6 are not equal. The sides must be proportional. Same ratio, okay? Same ratio, okay? So let's take a look at this example. So first of all, right off the bat, I know the angles are equal, okay? I got that. So I already have the angles are equal. So I already have my angles. But what about the sides? Well, let's see if the sides are proportional. So 4 goes to 6 as 6 goes to 9. Is that true? Let's reduce our fractions, okay? Divide by 2, 2/3. Divide by 3, 2/3. Okay, so here's what we have. The two sides are proportional. They have to have the same ratio. This must be the same. This ratio, they have to be proportional, and the angle. So we can say yes by side, angle, side, similarity. Okay, we just proved it, okay? All right, now example 3. If we know they're similar, okay, we've got triangle AMN and triangle ACB. Let's take a look. Two different triangles. I got a little triangle and I have the big triangle, okay? So now it's a little tricky with the big triangle. This big triangle, we're going to have to take a look at the big triangle. Okay, so the big triangle, before I do too much, this side on the big triangle, the length of this side of the big triangle is going to be 12 plus 18 is 30, okay? The whole length from here to here is 30. And the length of this side is 10 plus 15, which is 25, okay? So, here's what I want to do. If I want to find if they're similar, let's see if they have the same ratios, okay? So, we automatically know they share angle A, okay? They both have angle A. But what about the ratios? Is 12 goes to 30? Does 12 go to 30? Is that the same as 10 to 25? 10 to 25. Is that true? Well, let's see. If I reduce by 6, I get 2/5. Reduce by 5, I get 2/5. So we can say yes. Yes. By side, angle, side, similarity. Okay? Okay, last but not least, let's check this last one out, okay? So, first of all, let's make sure. I think these triangles might be turned around, and this is, I'm not sure, does R go to G? Does S go to H, or does S, I don't know, does R go to G? Or does R go to H? Well, here's how we can tell. R goes to H. So I'm going to mark it. So R goes to H. See how these two triangles have been flipped over? And S goes to G. Okay? Okay? And then finally, of course, T goes to K. Alright? I like to mark it. Okay, so that means that this side goes to this side. These two sides go together. Right? That means these two sides go together. That means this side here goes to this side here. Okay, can you see it? So let's find the value of x. So the first thing I gotta do is set up some numbers. Okay, so I'm probably going to go and do my 5 goes to 20/3 because I need to get a ratio. So that's kind of weird, but or I could do a different way. No, let's go these two because I know that. Okay, so 5 goes to 20/3 as 3 minus x. Oh no, we'll do the easy one. 3 as 3 goes to x plus 7. Okay, now, what am I going to do? Let me solve this by multiplying this one up here. We're going to cross multiply, okay? We're going to cross multiply. And multiply this one up over here. So we're going to cross multiply, okay? So we've done that before. So I'm going to get a 5 times an x plus 7 equals a 20 thirds times 3. Now that's like a 3 over 1. Okay, now this is going to get easy, right? Because I can see already the 3's cancel. Boom, boom. And then I'm going to distribute 5x plus 35 equals 20. Okay. Minus 35 minus 35. Got a 5x equals negative 15. Divided by 3x is negative 3. Okay. And that'll work. Okay, so if x is negative 3, 3 minus a minus 3, this side is 3. If x is negative 3, 3 minus a minus 3, the side is 6. If I put in negative 3 plus 7, the side is 4. There we go. All right, so homework today for you guys, and send it to me. Page 272, 1 to 6 all. Let's take a look at it. Page 272. 272, easy, easy, easy. 272, here it is. Page 272, 1 through 6 all. Just says determine if they are similar. So you got to make sure that the ratios are the same. And then 3, find the value of x. Oh, I think we just did that one. How do you like that, huh? 4, verify. Now you have to draw. I would draw the triangle. I would draw triangles. I really would. I'd draw them out. They give you what they are, but you have to draw them. And then on 5 and 6, again, I would draw another triangle. Okay, that's all I have for today. Talk to you Monday. Woohoo!